So now they want us to divide complex numbers. Well, it turns out we don't really divide them. What we do, so I'm going to write this problem down so I'll have it bigger. 2 plus 5i over 5 minus 2i. We use the same idea that we used when we were rationalizing denominators in a previous section. I don't remember which section. And we're going to multiply by the complex conjugate of the denominator. Now, the reason we're going to do that is so that we'll get a real number in the denominator, and then we can write it in what we know as a plus bi form. So we're going to get a complex number when we divide these, but that's how we approach the problem. Okay, so the first thing I'm going to do is I'm going to put parentheses around the numerator and the denominator. Now, a common mistake students make is they take the conjugate of the numerator, but it's got to be of the denominator. So multiply, here's the big idea, multiply by conjugate of denominator. Denominator. Okay, so look at the denominator, and what is the conjugate? 5 plus 2i. You got 5 minus 2i, so the conjugate is going to be 5 plus 2i. So we're going to do the same multiplication in the numerator, 5 plus 2i. Whatever you multiply in the denominator, you also have to multiply the same thing in the numerator. It doesn't switch, okay? Now it's a bunch of multiplying here, so it's a bunch of foiling. Okay, so we'll see what we can do. In the numerator, 2 times 5, that's 10. Then I'm going to have 2 times 2i, that's going to be plus 4i. Then I'm going to have 5i times 5, which is going to be 25i. And then finally I'm going to have 5i times 2i, which is going to be 10i squared. And I usually just write out 10i squared. I know it's going to change, but I'll just change it on the next step. Okay. Over. Now I could use that form that we had before on the last video. We could take the 5 and square it, plus the 2 and square that, right? So if you remember, it was when you have a minus bi times a plus bi, it equals a squared plus b squared. Okay? So that's what I'm going to have. Over here, I'm going to have 5 squared plus 2 squared. Now, if you want, you can just FOIL it out. So I do it all the time, but I'll leave that up to you. Okay, so in the numerator, what do we have? We have a 10 plus a 29i minus 10, right? Because that's going to be, that I squared is going to be a negative 1, so that's going to make it a minus 10. In the denominator, what do I have? 25 plus 4. Okay, now we still have to simplify. So in the numerator, the 10's cancel out, 10 minus 10, right? So I get 29i over, the denominator is also going to be 29. So this one's kind of different. It just simplifies to be I. They don't always do that. Sometimes you get, you know, a real part and an imaginary part. Sometimes you get fractions for the real numbers for a and b. That's okay. This one just kind of simplified nicely just to be I. Hopefully we'll have another example where it does more.